Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael, and in studio with us we have Isabella. And Isabella, if somebody needed to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Toll free 1-866-636-6284. Email dothemath@kern.org. We are online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Isabella, where do you go to school and what grade are you in?
I go to school at Panama Elementary, and I am in 5th grade.
Have you been at Panama for a long time?
Yes.
Since you were born?
No.
I'm only kidding, but like kindergarten or
Yeah,
TK or
kindergarten.
something like that? Okay, so you're pretty used to the way things run at Panama.
Yes.
Now, if I'm not mistaken, they're doing some remodeling out there,
Yeah.
even though you're not on campus right now. Did they start that last year when you guys were in school?
Yeah, they started that last year.
So what kind of things did you see them doing? Do you remember
I
any of
saw
that?
them like repainting the classrooms, adding more classrooms, changing the parking lot, adding like playgrounds and like new equipment.
So there's a lot of stuff going on.
Yeah.
So hopefully, if you guys are able to get back to school in March, you might be able to see some of the things. Hopefully they're all taken care of by now, right?
Yeah.
All right, good. So do you think you'll be in one of the new classrooms when you go back to campus, or do you know where your class would be already?
I think I'll be in one of the new classrooms maybe, but I think I know where my classroom is already.
Oh, good. All right. Any new play equipment out there that looked pretty interesting?
Not that I've seen, but the school looks great so far.
Oh, good. All right. Well, I'm sure you were able to drive by it and see things like that, so good.
Yeah.
Well, you know what? We've got about 57 minutes left in the show. Are you ready to do 57 continuous minutes of math?
Yeah.
Okay, I like how you laughed before that. Like, yeah, okay, old man. Well, if you think so, you're not going to have to do that much math. But anyway, I just wanted to see if you were ready for that.
Okay.
But I am going to have you work on a problem right now that is something brand new for you in 5th grade.
Okay.
All right? So head on over to the board. I'm going to read the problem to you. You can go ahead and write it up there.
Okay.
All right? So here's the problem. So start over on the left-hand side, kind of up at the top. That way you have some room to write.
Okay.
So 3, and then open a parenthesis. There you go, perfect. 6 plus 5. After the 5, put an X. And now close the parentheses. Good. Now minus 7.
Do I add a parentheses?
No, just put the 7.
Okay.
There you go. Now open parentheses. 2x minus 1. And then close parentheses. And this will be the first problem. And I know that this is something brand new to you.
Yeah.
All right. But we're going to go ahead and talk through it together so that if you start doing these in 5th grade, and you will next year, you'll have a little better understanding about it. Okay. So take a look at the problem right now. Have you ever heard of the distributive property?
Yes.
Okay. What does that mean? Do you remember what distributive property means, what you do?
Distributive property means like if you like switch out the numbers. Well.
Okay. Let's start with that. Okay. All right. So we see parentheses up there. All right. And when we see parentheses, what does that tell us we're going to do?
tells us that we are going to we're going to like add these together and separate it from that.
Okay. So the first thing we want to do is we see 3 and then parentheses and the 6 and 5x.
Yes.
Do you think we can put 6 and 5x together?
No.
No, we can't, because one has an x, a variable, and the other doesn't.
Yeah.
Right? So we can't put them together right now.
Yeah.
So let's multiply the 3.
Okay.
What we're going to do is distribute it. Okay, so draw a line from the 3 to the 6. All right, so what is 3 times 6?
18.
Good, so write that underneath it. Now, what do you think is the next step?
I think the next step is to times 3 times 5. 5x.
Perfect. All right, so go ahead, and what do you get when you do that?
15.
All right, and is it going to be positive 15x or negative, or do you know?
Positive 15x.
Right, positive.
So do I put plus sign right here?
There you go, positive, and then 15x. Okay. Now, has everything been done with that first set of parentheses?
Yes.
Okay, so let's move on to the next set.
Okay.
So now, what are we going to multiply?
So now we are going to multiply 7 times 2.
Hold
2x.
on there, sister, all right? Because most kids say that, all right? Is it 7 or is it something different? What's in
Something
front of the 7?
A minus.
And
So
what
we-
does that mean?
So that means we have to subtract.
Eventually
Divide.
we will, like it means subtract, but would that be a negative 7 or a positive 7 right now?
Negative.
There you go. So it's negative 7 times 2.
Okay.
And what is that?
Negative 7.
What's negative 7 times 2? Well, think about 7 times 2.
14.
All right. So erase the 7 and let's put a 14. Now remember, it's negative times positive. If you have a negative times a positive, do you know what that will end up as?
A positive.
Okay, here's what I want you to do. Over on the side, draw a big triangle. All right. Down at the bottom, on the inside, draw a plus sign. And on the inside, up on the 2 corners, put negative signs.
Oops.
Yeah, just like a minus symbol, a negative sign. All right. Now, here's how you can do this without ever making a mistake. Okay. Negative 7, right? So which symbol did we already use if it's negative 7? A negative or a positive?
A negative.
So cross out one of the negatives. Now, 2, was that negative or positive?
Positive.
Cross out the positive. What's left?
The negative.
So it has to be negative.
Okay.
All right, so put negative 14. Well, that's 14 minus, so the negative is going to go in front of it. There you go. Does that make sense? That's negative 14 now?
Yeah.
All right. So think about this. Negative and negative make positive.
Okay.
All right? When you multiply and divide a negative number and a negative number, until the day the earth is ended, it's always going to be positive. And if you ever have to, just draw your little symbol like that, and that way you can check to make sure.
Okay.
All right? Now, was it just negative 7 times 2, or was it negative 7 times 2 something?
It was negative times 7 times 2 positive.
Right. And was there any letter on there we need to worry about?
Yes, the positive.
And so let's put an X next to that 14. Okay. Now, okay, if we multiplied negative 7 times 2x, what are we going to multiply now?
We are going to multiply 7 times 1.
Okay. And are they positive or negatives?
One's a negative.
What's the other one?
The other one is a negative.
They're both negatives, right?
Yeah.
So think, first of all, what's 7 times 1?
7 times 1 is 7.
All right, so put a 7 after the x. Now, is it going to be positive or negative 7?
It's going to be negative.
Why negative?
Because the 7, because they're both, oh no, it's going to be positive.
Well, which
'Cause-
one is it? You said negative and now you said positive.
Because you said that negative times negative equals positive.
So what is it going to be?
Positive.
Then put a positive symbol in front of the 7. Whoop, on the other side of it. There you go. So that's positive 7.
Yep.
Okay? Now, read me what you wrote. What is that second line? Just read the whole thing, starting with the 18.
So it's 18 plus 15 positive, and then
Well, 15x.
15x, and then negative 14 times
Well,
positive 7.
14x.
Yeah, 14x. 14x times, or 14x and
Plus 7.
yeah, plus.
Right? Because the way you wrote it, it kind of looks like it might be times, right?
Yeah.
Okay. So let's think about this. Let's take the numbers and put them together. Are there any numbers that don't have x's with them?
18.
Okay, so underline that. And are there any other numbers without x's?
No. 14.
Well, 14 has an x next to it, right?
Oh yeah.
Are there any other numbers that don't have an x after them?
These numbers up top.
Well, we're not worrying about those anymore.
So no, there's no.
What about the 7? Does that have an x after it?
Oh, it has an x before it, so no. The 7 does not.
Right. So underline the plus 7. So what's 18 plus 7?
That is 25.
All right. So underneath on your next line, write 25.
I did not mean to do that.
Yeah, you just get rid of it, I think, because your hand maybe touched the board there. All right. Now, there are 2 things left up there that we didn't use. We already used the 18 and the positive 7.
Yeah.
What 2 things are left?
The 15x and then the negative 14x,
X.
yeah.
Right? So if we have 15x, now think about this. Let's say we have 15 apples, and we take away 14 apples. What do we have?
One
One
apple.
what?
One,
Apple.
yeah,
Right?
one
We have
apple.
one apple, right? Don't forget apple, right?
Apple.
So if we have 15 x's and we take away 14 x's, how many are left?
One apple. One x.
1x, there you go, all right? So after the 5, put 1x. Now, is that a positive 1x or was it negative? Did we end up with a positive 1 or a negative 1?
A positive one.
A positive 1. So we need to put a positive symbol in between there. So if you want to, you can erase the 1x and leave yourself a little room. So erase the 1x, that way it'll be easier to write. So put your positive symbol, plus, and then put your 1x. All right? Now, can you put 25, like a regular number, and a number with an x, can you put those together?
No.
No, you can't, right? Just like before, you can't put those together. So I know that's just your first one, but that's a little introduction to you on how to do expressions. So you feel pretty good?
Yeah.
Good. We're going to do another one in a minute and see how good you feel about that. So anyway, 636-4357 is the phone number. We do have phone tutors available until 5:30. Time now for today's Math in the News. All right, today's Math in the News has to deal with the California brand new, well, they're not going to be new, but the new mathematical content standards are coming out. Are you aware of this, April?
I am not. Thank
No,
you for the
what?
news.
Well, they're starting to put it together. All right. So that's what we're going to look at today. And they want input from educators and parents as they're putting this thing together. So we're going to take a look at, since Isabella's in 5th grade right now, we're going to take a look at some of the examples that they want them to do. So in 5th grade, fluently multiply multi-digit numbers using the standard algorithm. Now, Isabella, do you have any idea what that means? Fluently multiply multi-digit numbers.
No. Well, so like multiplying multi-digit numbers.
There you go. That's basically it, right? Fluently means you can do it without much difficulty and pretty quick, right? Can you do 2 times 3?
Yeah.
What is that?
6.
No, you do that fluently,
fluently.
right?
Yeah.
That's what that is, okay? Now, multi-digit, what do you think that means? Can you give me an example?
A number that has like more than one digit, so like 132.
Okay. Now how many, that's 3 digits, right?
Yeah.
If I only had 2, would that still be multi-digit?
Yes.
Okay. So how about you guys erase the board real quick?
You can,
There you go, she got the trick. All right. So April, come up with a 2-digit number for Isabella to start with.
52.
All right, so write 52. And Isabella, you come up with another 2-digit number.
15.
What is it?
15.
15?
Yes.
All right, so put 15 wherever you want, either next to it or under it, however you normally multiply. So you want to do 52 times 15. Do you think you can do that problem right now for us and explain it to us?
Yes.
All right, go ahead and do it for us. And explain it as you're going.
Okay, so here's how I would multiply 52 times 15. So first I will break apart 50 and then times it by 10, and then I would get 500, and then I times 50 times 5, and then I get 250, and then I do
Just make sure your hand doesn't touch the board. I think that's what's making some of those little marks on it.
okay.
There you go.
Then I do 2 times 10. Oops, I need to switch them. Then I get 20, and then I do 2 times 5, and then I get 10, and then I just add them all together. So first I'm going to add these 2 together. And then I'm going to add these 2 together, and I know that's already 30, and I already know the math in my head, so then I get this.
So you added 20 and 10 for 30 and added that to 750?
Yeah.
Good mental math.
So there you go, nicely done. So you got 780. Now,
Yeah.
April, let's take a look at what they had on the board here. It says, now fluently, you had no problem with that, right, Isabella?
No.
So I would say that that was pretty fluent.
That was
all right.
fluent.
You multiplied multi-digit numbers. Now, using the standard algorithm. Now, April, do you think the way she just did it is what people would consider the standard algorithm or another way?
That would be another way. That is not the standard algorithm.
Right, and that is beautiful what you just did.
Conceptual.
Because guess how many ways there are to multiply those 2 numbers?
A lot.
Give me an idea. What do you think a lot?
4.
How many different ways do you think there are to show that?
4.
You think there's 4?
Yeah.
I bet you there's 5. You think there's more?
Yeah.
How many?
Like 7.
I bet you there's 8. You think there's more?
9.
I bet you there's 10.
11.
You really think there's 11 ways to do that?
Probably not.
I bet you there are. But we're going to show you one more way how to do it, okay?
Okay.
And you might remember this. So April, if you want to go over how to do that,
Can I come up to the board?
yeah, come on over here, Isabella. There you go. And that
Okay.
way it might
So
be easier for
Isabella,
April.
we're going to multiply 52 times 15. And when you use the standard algorithm, we're going to stay right here. So we're going to multiply, taking the ones column here, 5 times 2. And 5 times 2 is?
10.
10. So I'm going to take 10, and that's the ones, and I'll carry this over to the tens column. So then I'm going to multiply 5 times 5. 5 times 5 is?
25.
And to that, I'll add the
20.
10, so
So
that'll
it's-
be 26, because that's in the tens column, right?
Uh-huh.
Okay. And then I'm going to put a placeholder here, because I'm done with the ones column, so I'll be done here. And now I'm going to multiply the tens times the 1. So 1 or 10, 1 times 2 is?
1 times 2 is 2.
2. So then it's in the tens column. And 1 times 5 is?
5.
And then I'm done multiplying, so I will add straight down. And 6 times 2 is?
8.
I mean 6 plus 2.
8.
Thank you. And 2 plus 5.
7.
And our answers match. And we did it different ways.
Now, had you ever seen that type of multiplying like that?
Yes, many times. It's just sometimes I forget it.
Right. And which way do you feel more comfortable multiplying?
Probably this one.
Right, the way you did it first, right? That's
Yeah.
the most
That's-
comfortable, right? You would go, oh, let me do the way that I feel most comfortable doing this, all right? Now, April, are you comfortable showing Isabella or working with the area model?
Yes.
All right, so Isabella, here comes way number 3
Okay.
that we're going to multiply these two numbers. All right, so we're going to keep the same numbers, 52 times 15.
So I'm going to split this so that this is 50 and 2. So 50 plus 2. And then 15 would probably be more here. So then this would be 10 and 5. So I'm going to use those same numbers that you used, right?
Okay.
So here's the area model. So I'm going to find the area here of each section. So 10 times 50 is,
500.
which one of your numbers, right? And then I'm going to find the area here. So that would use this number and this number right here. So what is 10 times 2?
20.
And now I'm going to find the area here using this number and this number. So that's going to be 50 times 5.
250.
And then I'm going to find the area here. So that would be this number here and this number here, which would give me,
10.
let's multiply. All those numbers look familiar, don't they?
Yep.
What is 500 plus 250 plus 20 plus 10?
That's 780.
Yes. And that's the area model.
You are a math whiz. 3 different ways to multiply, huh?
Yep.
You think there's another way?
Yeah.
Yeah, of course there is, right? There's going to be countless ways to do this, but we're going to stop at 3, all right?
Okay.
Now, you have done some excellent work thus far, but that is today's Math in the News, taking a look at the standards. And for your great work, you've got yourself a meal courtesy of our friends at Broken Yoke. Have you ever been to Broken Yoke Cafe?
No.
Oh, well, this is going to be exciting for you, because if you're not able to actually eat there, you can get a meal to go, and there's some great food over there. Just look at me. I like it. All right. Hey, you know what? We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Don't forget, if you need to email us a math problem, you can do so at dothemath@kern.org. But please try to do it on a Monday, Tuesday, or a Wednesday during the day. That way, when we're in studio and broadcasting live on Tuesdays and Wednesdays, we can address that problem and present it to you on a Tuesday, Wednesday. If at all possible, that's the best way to do it. All right? We'll be back with more right after this.
As we continue to follow the flow of the water, we're at our next stop, the flash mix. Dave, what is going on with the flash mix?
That's a good question, and I think it's one best suited for our water production facility superintendent. This is Kelly Ulrich.
Well, the flash mix is where we actually inject our chemicals. This is where the raw water is introduced to the chemicals, is the first phase of the treatment process.
And Kelly, what is your official role here at the plant?
I am the superintendent. I am responsible for not only the treatment of the water, but the distribution of the water as well to all of our purveyors.
That's very interesting because this seems like sort of a niche job. How exactly did you get into it, and what do you find most enjoyable about it?
Well, I actually didn't fully intend on becoming a superintendent at a water treatment facility. My degree was in biology, and I just by chance happened to work for a temporary organization and started at the very bottom of pulling weeds and painting pumping plants, and then just progressed through the ranks over time.
And how long have you been with the agency now?
I've been with the agency going on about 12 years. I've actually been in the industry going on about 30 years.
So, Kelly, when I'm at home, I turn on the faucet and I know that clean water comes out. So, I'm not very good at chemistry. Give me a crash course here on what chemicals are being used and how that's treating the water.
First of all, our pH coming in is approximately 8.5, and so we have to reduce that down to help our treatment process. So we reduce it down to about 7.2 by the introduction of sulfuric acid. After that, then we introduce our primary coagulant, which is aluminum sulfate. The aluminum sulfate, it actually takes the particulates and coagulates them. It takes them and puts them into small masses, and we actually call the little small masses flock. And sometimes we introduce a cationic polymer, which helps strengthen that flock, and it actually makes the flock material larger so that it can settle out in our basins.
How long does it take to go through all of that?
Our minimum flow that we operate is about 14 million gallons a day. And for a molecule of water to start here at the flash mix and get through the treatment plant, at the low flows, it would take about 5 hours. And at the higher flows, about 50 million gallons a day, it would only take about 2 hours till the end of the filtration process.
And based on the water that is coming in, because you've got water coming from different resources, does that affect a great amount of how you treat the water?
Yes, right now we're treating groundwater, which is very easy to treat. We don't have to use as much of the primary coagulant, sulfuric acid, the cationic polymer, as well as our primary disinfectant, which is sodium hypochlorite. Those are minimal versus when we're treating water that may come off the California aqueduct, then our treatment chemicals probably double and triple in order for us to meet the standards that we need to meet for the State Department of Public Health.
All right, well, Kelly, we're following the flow of the water as we're going through the entire treatment plant. Once it hits this flash mix, what's the next stop?
After the chemicals are introduced, it goes into each one of the treatment trains. We have 2 treatment trains. The next stage is what we call flocculation. At that point, we have flocculators, which are mixers, and they kind of help mix the flock so that it actually, we get this biggest, heaviest flock possible by the time it hits our sedimentation basins, which that's where we like the flock to fall.
John, have you ever seen flock fall?
Never.
Neither have I.
I just thought it came from the clouds to my tap. I mean, this is incredible.
Well, let's continue with the process and see where it leads us.
These are dual media filters that mainly consists of the anthracite, silica sand. Those are the main components, and then a small amount of gravel is used for support.
Do the math, do the science, do the water, do everything we possibly can to help any of the students out there. We do have phone tutors available until 5:30 this afternoon. April is in studio with us, and it is time now for our visit from Science for Kern. All right, we always look forward to these challenges. Jamie, how are you today?
Doing well, how are you?
I'm excellent myself. Now, I know that a lot of times the activities that you do with the students in here are hands-on activities, but this really is a little more hands-on, isn't it?
Yes, it is, and I'm here with Isabella, and we're going to get started today with a 5th grade science concept. So Isabella's a 5th grade student, so I'm going to help her understand a little bit of chemistry today. So we're going to go ahead and get started. You ready?
Yep.
All right. So the first thing we're going to do is something that lots of kids like to make. We're going to make slime. So what we're going to do is we're going to use your basic glue. So you can use regular white glue or clear glue. And I know a lot of students like to use a wide variety of stuff, but I'm going to use liquid starch because that's something that you can find at home. But I do know you can use foam soap. You can use saline solution. There's a wide variety, but we're going to use liquid starch today. So are we ready?
Yep.
Okay, so right over here, we already have some ingredients for you. And so what we're going to do is we're going to take our cup, and we have a half a cup, and go ahead and pour your glue in there. So after we get that glue in there, we're going to go ahead and pour it in our larger cup. All right, there we go. We'll clean it up. Okay. So go ahead and pour it in there. All right. And then we're going to take a half a cup of water. So it's the same amount of glue and water. I'm gonna add a little bit more there. All right, so what I want you to do is go ahead and take that stick and go ahead and mix it up. How does it feel so far?
Feels good.
Yeah, okay. All right, so then we're going to do the same thing with our liquid starch. So all I did was take this liquid starch and pour it into a cup, but we need a half a cup. So we had a half a cup of water, half a cup of glue, stirred it up. But before we do that, what kind of color do you want your slime to be? I have red, yellow, and green, and then you can always mix two as well.
I'll do yellow.
Okay, so go ahead and put your drops in there. And this is just basic food coloring. All right, go ahead and stir that up. Now you can go darker if you want. Is that good yellow?
Yeah, that's good.
It almost matches your sweatshirt today. All right, so let's go ahead and pour that liquid starch right in there and get a half a cup. Okay, and then we can go ahead and pour it into our larger cup. Go ahead and mix it up. What does it feel like now?
On the bottom, it feels like gooey, and then on the top, it still needs to be mixed a little bit more.
Okay. Does it feel like it's getting a little bit harder when you stir it?
Yeah.
Okay. Now, if yours comes out a lot, it has a lot of water, you can always add more liquid starch. But sometimes when you add too much liquid starch, it gets really hard. And then it's not slime anymore.
Yeah.
So what we're going to do is we're going to come back to this. Look at how great and awesome this is. Look at that. Look at that slime. It's great, huh? So what we're going to do is we're going to look at that, and we're going to learn a little bit about the science concept behind some of this. When we look at states of matter, we want to talk about, we normally talk about three. There's more than three states of matter. But one of them is what this ball is. Now, do you know what the three states of matter is?
No.
Okay, so this would be a solid.
Okay.
Okay, can you give me another example of what a solid would be? Would this be one?
No.
Okay. Would this table be a solid?
A ball?
The ball is a solid. What about this?
That is.
We know it's a pen, right?
Yeah, it's a
Okay.
pen.
Okay. So we're going to get into a little bit more. Okay. So I have a ball, I have a pen. You said this one wasn't a solid, but this one is.
Yes.
Okay. So let's go over what the definition is of a solid.
Okay.
So a solid is anything that keeps its shape. So if I take this cup and I put it in there, did it change shape?
No.
No, it didn't. Okay, it stayed the same, right?
Yes.
So it's a solid. Now what if I put that in there? Did it change its shape?
Yes.
It changed its shape to what?
Oh, no.
No. Okay. What if I put, let's do the stick. Did it change its shape?
No.
No. So is that a solid?
Yes.
Right. So is this pen a solid?
Yes.
Okay, so we got that. So now we know what a solid is, right?
Yes.
Usually when you put it in here, it's not going to change its shape.
Yes.
All right. So when we draw it in science, we like to look at atoms. So if I was to draw a solid, I would draw all these little circles. So I'm going to draw a cube. Because did it fill the whole cup?
No.
No, because when we look at it this way, it didn't fill the whole cup.
Yes.
All right. So we know that this is a solid. Okay. Now that you know that one state of matter is a solid, do you know what the other ones are called?
No.
Okay, so let's go on some more. Now, this is just yellow water. Okay. Do you think water is a solid?
No.
No. Okay, so it's got to be something else. Do you know what it is?
Liquid?
There you go. There's our next one. So we have a solid and we have a liquid. Now, what's interesting about a liquid is the definition says it's not going to keep its same shape. It's going to change its shape. So if I had a different container and I poured it in there, what happens to the shape of the water?
It like gets rounder and it like goes like waves around kind of.
Well, it changed, right? It changed to
Yeah.
this shape, right? But if I pulled it back in this cup, what happened to the shape?
Changed back to that shape.
Right. So definition of a liquid is it's not going to keep its same shape. It's going to be the shape of whatever the container is, okay? So how would we draw that on here? How would we draw our molecules? How do you think? You try it out. You just draw it on this one.
Probably maybe like this
Mm-hmm.
and like color in.
Right. So that coloring in is probably like millions and billions of little tiny circles.
Yeah.
Okay, so our circles would go all the way across. So what's interesting about the molecules in a liquid is they just slide past each other. All right, so what do you think the last one's going to be? If you know this one's a solid, a liquid, what's the last one going to be?
Maybe like
That's okay. Let's go on from here. So I actually have this one is this right here. I might catch some in there. So there's something
Air.
in there. Okay, so do you know what what state of matter air is?
the third
The third one. So it's going to be a
gas.
gas. Okay, so what do you think those molecules are going to look like? So if I covered it up, what do you think they're going to look like?
Little tiny balls.
Go ahead and draw it in there. Now, why do you have them spaced out? Do you know why?
Because the gas like roams around everywhere. It doesn't just stay in one place.
Awesome, you're right. That's so cool, huh? So we can look at these different ways that the atoms are set up in our cups. All right, so now let's go back to the slime. Okay, this is what our slime looks like. What type of state of matter do you think this slime is?
I think it's liquid.
Okay, why would you say that?
Because if you were to put it in a different cup, it wouldn't stay in its same place.
Okay. All right, do you think, if I say it's a solid, would I be right or would I be wrong?
Wrong.
Okay, now tell me why I would be wrong.
Because if you were to like pour it into a different cup, it would not like stay the same shape as it did in that cup.
Okay, so what's interesting about slime, it all depends on how well you make the slime. So if I'd made this slime and it didn't stick to the cup, so I prod it out and I have it in my hand and I start working on it, it actually will become a solid. So what's cool about slime is it can be both.
Oh.
Yeah, it's pretty cool, huh? So this is called a Newtonian, a non-Newtonian fluid. So it has the same characteristics as both of these. Okay, there's another one, another non-Newtonian fluid that's cool too that you can do at home. So let's check this out. So what we're going to do, this is regular cornstarch. Go ahead and get that cup.
This cup?
Yep. And I want you to go ahead and get a cup of that cornstarch and put it in there. You can just put the cup right in there. Put it like this. So you take your spoon. Let me see your spoon. All right, we're gonna put it right in there. All right, now take a cup of water and pour it in there. So all we did was take 1 cup of cornstarch and we're taking 2 cups of water. So it's always 2 to 1. Okay, put the other one in there. All right, now go ahead and stir it up. There you go. Yeah, it's gonna be a little hard to do. Now, if you want to get your hands a little bit dirty, you can get your hands in there too. It's really fun. Okay. And if you ever get any on your clothes, it comes right off.
Okay.
So your just put it in the wash machine. Now, what does it feel like?
It's like liquid on your hand, but then when you put it back in, it's solid.
Okay, so let's grab some and put it in your hand and try and make a ball out of it.
It won't.
What happens in your hand?
It melts in my hand.
Right. So if it ever is too runny, like this could be, we could actually add a little bit more. All right, and then we get our hands in there. Try it again. How does it feel?
Feels the same.
All right, so now that we can try and make a ball with it. And then put it in our hand and then see what happens.
It
Okay,
just
so which
melts.
state of matter would this one be?
This would be solid and liquid.
Right, so it's just like
The slime.
right? So it's a non-Newtonian fluid.
Yes.
There we go. Isn't that cool?
Yeah.
So it's pretty easy. Cornstarch is pretty cheap that you can buy at the grocery store. And again, it's 1 part cornstarch, 2 parts water. Well, Isabella, I think you're going to have some fun when you go home with some of this stuff. But teachers, you can check out this matter kit on scienceforkern.org. We have multiple kits available for you in distance learning, and you can check them out. We deliver those kits to your school. Everything is ready to be sent home so that students can do hands-on learning at home during this time. So I'm going to take it back and
All right, thanks for
to you
that,
guys, and
Jamie.
thank you so
Always a
much.
great lesson when you guys come down from Science for Current, so thank you for that. While Isabella gets cleaned up, we'll be back right after this.
Okay, let's go get your hands.
Hello, it is Buzzy from Camp Keep, and today we're going to step away from natural history studies and we're going to go into the kitchen. And today I'm going to teach you how to make Buzzy's famous green smoothie, which I know a lot of people have been waiting for. And so there's basically 3 things that you need to make a really good green smoothie. Obviously the first thing is greens, and there's some kale. You could use parsley, you could use spinach, you could use any kind of greens. And those are important because those provide so many of the nutrients we need. And the whole point of a green smoothie is to try to get these good stuff in our body without having to like chew up all this stuff and eat. And so we're gonna make a nice sweet drink that we can use. So in this case we have greens. What makes it sweet are the fruits. You can use apples, oranges, bananas, just depending on what you like. The third thing you need, which is really important, is a fat that'll kind of bind together and make those things assimilate when you digest them. So I like to use any kind of nuts for my fat. You can use yogurt, but I'm a big fan of nuts. So these are almonds, we got some pumpkin seeds, walnuts are great, hemp seeds. It's really your choice. That's what's fun. You can always mix it up a little bit. All right, so, and then if you really want to just get into it, you can add like different powders like spirulina or chlorella powders. Any of these things will work. So let me just show you what we do. So I'm going to take some parsley and I'm just going to cut off a little bit. We're going to add some parsley. That's really good. We're going to add a banana. Okay, pretty simple. Take that off. You just chuck it in there. And let's add some pumpkin seeds. So we got our 3 main ingredients. And we're going to be a little fancy today and add some chlorella powder because that's really fun. Not needed, just something fancy. And then the last thing, of course, got to add some water. So you just put it to the top where it reaches the top. We then take our blender over here, put it on over here, and if you have any kind of good blender, this is a Vitamix, but there's all kinds of NutriBullets and all kinds of other good blenders. And we're going to do it for 20 seconds. Our green smoothie is done. We're gonna pour it into a cup, all right? Nice and smooth. And then we're gonna give it to a customer here. This happens to my son, Odin. And how is that? Pretty good? So that's a banana, parsley, pumpkin seed smoothie. And you drink that down, you've got 100% of all kinds of good minerals and nutrients.
Banana, parsley, and pumpkin seed. A green smoothie that young man was enjoying. Oh, a delicacy from Camp Keep right there. And, I don't know what that was, but it's good. So is that something that you might eat? Banana, parsley, and pumpkin seed smoothie?
Probably not.
Probably not.
Isabella
Well, you know
just
what?
told me she'd try it.
That's right. Now, next year you're going to be in 6th grade. And 6th grade students have an opportunity to go to Camp Keep, so hopefully next year you do have that opportunity, and who knows, you may have a green smoothie and go, hey, Mom, Dad, you know, I need green smoothies here every week now. Anyway, we do have phone tutors available until 5:30. Ooh, I guess somebody in the back doesn't like the green smoothie, but got that right. All right. Isabella, you're working on figuring out the volume of some different shapes. So why don't you go ahead and explain to April how to do the volume of what you've got on the board.
Okay, so first to find the volume, I would split these two in half. So I would split them like this. And now to find the volume of both of them, so first we know that this is 6 inches in total, but that can't be the actual height because we split them in half. But I know that the volume of this one is 3 inches, so that must mean that the volume of this shape must be 3 inches. So the height is 3 inches.
So you're saying that because the height here is 3 inches, and when you cut that line off, this has to be 3 inches as well?
Yeah.
So the other piece is 3 inches?
Yes.
Okay.
So I'm just going to write that for the height.
And how do you find the volume? Is there something that you use?
Yes, width times height times length.
Okay.
And then I already know that this is one of the numbers, nothing has changed about it because we cut it in half and this number has nothing to do with this. So that is the width, I think.
Okay. So we've got 2 inches for the width and 3 inches for the height. And the other piece we need is the
length.
Okay.
So for the length, I know that this right here is the same as this. So that means that the length would be 5 inches because they're the exact same. So that means that the length would be...
And right now we're going to find the volume of the box on top, right?
Yes.
Okay.
So then I multiply them all together. So I would
So in order to find volume, we're going to multiply the height times the width times the length?
Yes. And then from these two, I would get 6. And then I just bring this down. And then I have 30 inches. Cubic.
Why is it cubed?
It's cubed because that's the volume, and it has cubic inches. And the reason it's inches is because the numbers we start off with are inches.
Okay. And can you put your little cubic inch there?
That's right. Oops.
Okay.
And now we have to find the volume of the bottom one.
The bottom box?
So to find the volume of the bottom box, we don't need to change any of our numbers because we already have all the numbers of our bottom box. So we would do 10, and 10 is for the length.
10 is the length. That's how long the box is.
So we would do 10 times 5 times 3. 5 is the width.
5 is the width.
And then 3 is the height.
Okay.
So then we would do this, and we would get 50. And then we bring this down. Then we get 150. And now all we have to do is add 30 or 150 cubic.
And because it's a composite figure, you're going to take one box, the volume of one box, and add it to the volume of the other box?
So now we add them together. So and then we would get 180 cubic inches.
Very nice. And you know why it's cubic inches? Because it's inches times inches times inches, and you do that 3 times, and that's
To
what
get
makes it
cubed.
cubed.
Or you could also do 108
There you
3.
go.
I was going to say, that's
cubic
probably the
inches.
way most
I was
students would write it
gonna
like that. But when you did the abbreviations like you did, that's acceptable as well, because that does represent cubic inches.
Cubic inches.
All right, nicely done. So you feel pretty good doing those volume problems, huh?
Yeah.
Comfortable with that? Good. Erase the board, young lady. And have you ever heard that it's good to struggle with math problems?
Yes.
Well, you can hear it right now too, right? So in order to learn more and have your brain develop and grow, it needs to struggle a little bit, right? Because everything you know now about math, did you know it when you were 2 or 3 years old?
No.
No, you had to learn it, right?
Yeah.
And you learn a little bit at a time, and gradually you learn more and more and more, and your brain develops, right? So as you struggle with things, that's the key, right, in order to learning, because nobody knows everything,
Yeah.
right? You've got to learn things, okay? And you learn sometimes by struggling, and that way you learn it a little more and a little deeper. So remember earlier we did an expression,
Yeah.
and that was the first time you ever did one of those, right?
Yeah.
And you learned a little bit about how to do those. So let's do one more. What do you say?
Okay.
All right, that's what I like to hear. All right, so let's start up, put a 3, open parentheses, 6 plus 7x, close parentheses, minus 5, open parentheses, 4x plus 9. So now what I'd like you to do is kind of explain to April what you remember or what you think you're going to do, and if you get a little stuck, April's right there to help you out.
Okay, so first I would times these two together, then I would get 18, and then I would times these two together, but you can't times them together because 7 has an x at the end,
So you can't add them together because
Yeah.
7 has an x, but you can multiply them together. So go
Yeah.
ahead and multiply 3 times 7x.
and then I get, oops, 14x.
Multiply 7 and 3 one more time.
Oh, sorry.
And then bring it down at the same level of the 18 when you write it.
I forgot. 21.
Okay. Yeah, leave that space in there. And then is that a positive 21x or a negative 21x?
That's a positive.
So between the 18 and the 21, put a plus sign or a positive. There you go. Okay, now what? Now here comes the test. Tell me what you remember.
So now
Are we done with the first set of parentheses?
yes,
Yes.
we're done with the first set of parentheses. So now I add them together.
What about that that 5 there? Are you supposed to do something with the 5 in that set of parentheses?
Yes.
Yes. So what should we do?
So first we should,
Same thing.
same thing,
Right.
so then I would get, let me do this quick and put it to the bottom. So then we
And
would
leave
get
space.
20. Oops, I did. So then we would get 20x.
So 5 times 4x is 20x, but
Yeah.
is that a positive 5 or a negative 5?
That's a negative, so
So
we
do you
can't
remember
that.
that? So what do we know about our 20x now that we've realized that that 5 is negative?
So now we have to add a negative in the front.
Okay.
Now, are you positive that's what you do? I just want to check. I want to make sure you're good with this instead of just taking a shot at it. Why
So
is it a negative 20x? Why not just positive?
Isabella, do you want to put your triangle back up and see
Yeah.
if you can use
There
that
you
to
go. Right? So instead of her just taking a shot at it and getting it, I want to make sure she understands why it is.
So there's,
So you write 1 positive and 2 negatives.
so we used one positive already. So we,
Well, actually, if we're looking at the 5 and the 4, that's what we're going to look at to.
okay,
So if we used a positive, what is our positive that we used?
we used this one.
Okay, so we use that positive.
And then we used a negative,
Okay.
so we have one negative left.
And so that's why.
That's why it's a negative.
Yes.
So then,
So now what are we going to do?
so now we do 5 times, or 5 times 9,
Okay.
and then we get
Leave
45.
some space. So how do we know which symbol to put in between that 20x and that 45? Is it going to be a positive or a negative?
A negative,
Why?
because the 5 is a negative.
And the 9 is a...
Negative too. They're both negatives.
Is it? Look at it again. What symbol do you see in front of that 9?
A plus sign.
So that means it's a positive.
Okay.
And then if there's a minus sign, it
That means it's a
represents
negative.
a negative.
So then it's a negative. A positive.
So go back to your triangle.
Make a new one if you need to.
So we used negative and positive.
That's a times. Make sure your positive looks like a T.
Okay.
More like a T than an X. Okay, so what do we use?
So we use.
Tell me the number that is positive and the number that is negative.
Okay. So we use a negative from the 5.
Okay.
So we cross that out. We used a positive from the 9.
Okay.
So we cross that out, and we have a negative left. So now that would be negative 9.
Negative 45?
Yeah, negative
Okay.
45.
So that works. So now what?
And now we.
Pick up the speed a little bit, sorry.
Now
That's
we
all
add
right.
them
Just do
together.
the X's
Okay.
first.
So let's underline the X's, the terms with X's.
Okay, so this one and this one.
Yes, remember the little apple analogy? So if I have 21x minus 20x, that would give me
1.
1.
X.
Yes. Good, there you
So
go.
now we have 1x.
1x.
And this one you may not be able to do in your head, but what's the difference between 45 and 18? Like, just go ahead and do it on the side if you want to. 45 minus 18.
$27.
Good. So you have the 1x, and then next to it, leave some space, put your 27
Right here.
down next to the 1x.
So,
Leave some space.
oops.
Because we have to put a positive or negative in between.
And if you're wondering what that is, what number is bigger, 45 or 18?
45.
So that's why it's going to be negative. So put a negative 27. There you go. Nicely done. Hey, did you have some fun today?
Yeah.
Good. That's what I was after. And guess what? We do have phone tutors until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.